So we're going to have to cut it a bit fine. I'm planning to cut a little bit out of the break in the middle. So anyway, hello. Hello. Thank you all for coming. I haven't done this for a long time. I used to organise technical meetings an awful lot, but I don't think I've done it for about 15 years. So apologies if it's not quite as slick as it would be if Tom was doing it. So anyway, start off. Thank yous. Thank you all for coming. Thank you all the speakers for volunteering to speak. Thank you to Perl, who are sponsoring, who have paid for the beer and the pizza, and for renting this space, which is, we've never been here before. Oh, it's quite a nice space. I think we should come back. So you'll be hearing a little bit more from Perl a bit later on. We have. Well, in theory, we have 6 talks tonight. There were 5 on the list. I got here and found out that there was one more. But one of my speakers isn't here yet, so the second half's going to get a little exciting. There's probably fire exits and stuff like that I need to tell you about, but you'll find them. Follow me.
There we go.
We're not planning a fire drill.
Good. At that point, I will just welcome you again and hand over to Colin.
Thank you. Can I steal your seat?
No, it's my seat.
Okay, so this is a talk about security education and for developers, since that's my assumption that most of us here are developers. So, who am I? I'm Colin. I work at a company called CV Library, not far from here, or at least my office is not far from here. They're actually based in Fleet as well. Anyway, got the obligatory reference into capital recruiting. So what I'm really talking about is educating software developers, because it should really be easy. Most of the stuff that we have to deal with security-wise is actually quite simple. And yet, as far as I know, it's not really. We're churning out graduates who get a brief idea about security. We recently apprenticed a sixth former at a previous company, and they've been given like a summer course where they've been given a booklet on doing a bit of web development. And on the front page it was the XKCD Bobby Tables thing, and yet on like page 2 it was showing them how to do SQL queries with SQL injection included. And on like the final page it was, oh, by the way, you might want to fix that. And it kind of feels like we're doing a pretty bad job of educating our developers. And as far as I know, there isn't a decent book reference. There are sort of good books that mention security, but they're not necessarily designed for developers, and certainly not for our programming language in particular. And I haven't come across one for any particular programming language on the whole. And probably the closest thing would be perhaps say Safer C, which is designed for programming in C and about making your code as robust and safe as possible, so that if it runs in nuclear parlance and things like that, it's as robust as possible. And if it's that sort of robust, then it should also hopefully be secure, although that's not necessarily quite the same thing all the time. The OWASP obviously have guidelines, and that's what a lot of people point to when it comes to educating about security. They're not just for us as an audience. So what I've written here isn't, it's perhaps a bit disingenuous, but essentially the audience isn't solely developers, it's security people, it's for other people as well as developers, and so it gets a bit muddy in places. And you know, we could really do with guidance designed for developers, because one of the things I tend to get wound up about at security meetings is people going, oh, it's all about the things you allow and disallow, all the inputs you allow and disallow. Whereas most of the time, from a developer's point of view, it's actually more about encoding your inputs correctly. So that things like O'Callaghan as a name don't blow things up, because that's a straight up bug. And we shouldn't be disallowing characters like apostrophes simply because they might blow up SQL. We should be encoding our things correctly so that we don't have problems. And then we can think about what we allow and disallow as a separate problem. So, as I was saying, security on the whole isn't generally hard. A lot of the time, it's all down to us using strings in various places in different contexts and different languages. As we have in our Perl script, SQL, which is another set of strings building up another language and then going to another interpreter, things like that. And we're building up HTML and things like that, which again, when we're building up all these strings, there are all these different chances for us to append in something that ends up meaning something semantically different in that context, which is obviously problematic. But at the same time, there are a few hard bits. Cryptography tends to be one of them. I mean, a lot of the basics are actually quite straightforward, and finally we are starting to see libraries with good interfaces that make it easier to do cryptography. But it's surprisingly often that you come across developers who, because they've come across one of the hard bits of security, they just sort of throw up their arms and just ignore security and say, oh, I'm going to leave that to someone else to sort out, or I'm going to look at it at the end, or whatever. You know, they prefer we'll just leave it to never. And, you know, I've given talks where I've had some come and say, oh yeah, it was brilliant, but I'm not the person who deals with security. And it's kind of frustrating because, on the whole, most of us have to deal with it. You know, it's only in very small fields where you can get away with not doing it, where you've either not got external users or, you know, nobody's using your code, really. So, as an example, I mean, SQL injection, we essentially, code-wise, we should have solved it too. You know, we've had placeholders for a long time. Perl was probably, you know, one of the earlier languages to help solve these sorts of problems. You know, DBI's been around forever, placeholders have been around forever. You know, it seems crazy that SQL injection is still a problem that is, you know, plaguing lots of people, and we're still seeing lots of database breaches with it. And part of the problem is simply that we've only solved part of the problem as well. Because with SQL injection, we've got all these placeholders for all of our arguments, but we don't have it for helping us to build up the query in general. So if we want to do a dynamic query where we might have variable numbers of arguments, you know, various different clauses, that kind of thing, or even joining different tables, that kind of thing. Of course, we do have ORMs, but, you know, they end up with religious wars over whether to even use them to some degree. And you also have to make sure you've turned on the right flags. We do in class, for example, you really need to turn on quote names. Then you've got reasonable SQL injection sort of prevention out of the box, as it will quote all of the things it thinks are identifiers out of the box correctly, so that if you do end up passing some untrusted input into a place where it's not expecting it, the worst you'll get is an error from the SQL rather than actual somebody being able to do something quite semantically different to what you intended. So there's also the fact that we're obviously not educating people well enough about using placeholders, and as I was mentioning, that sixth form pamphlet where they was showing how to append the strings to generate the SQL on a simple scenario where you should be using placeholders. And like I say, we've only solved half the problem, at least say at the DBI layer, in terms of actual dealing with placeholders and things like that. So how do we normally teach our developers? We have coding standards, we do things like code reviews hopefully, and we obviously have our testers testing their code. And you know, there's generally some mention in some of the textbooks about security, but it's generally sort of and again, lectures and, you know, universities and teaching courses. So I wanted to talk about some other ways that we can teach developers. There are these things called capture the flag competitions, which are kind of like online games where you have technical challenges, and the idea is to say, hack the application to get out some piece of secret information from it. And those are really good ways of actually gaining practical experience of seeing how a vulnerability is exploited. And often they'll give you the code of the server so that you can have a look at it, possibly play with it on your own machine, and then you can try it and see if you can get the flag out of the thing. PHP tends to be a really common one because people are quite easily able to code up challenges, and there are problems with PHP that a lot of people are still, you know, contending with. But there are ones written in various applications, various languages. I haven't actually come across one written in Perl. But Gruyere is one that, well actually, sorry, that's a slightly different thing. So there are capture the flag competitions, and then there are also vulnerable web applications that people have built. And again, that's done in various different languages. Capture the flag competitions are often actually in lots of different languages. And there are some where there are quite good contests and things, where you can win prizes and back to conferences and things like that. And there are some that are run by universities. And even some companies actually use them to help hire. They go around universities and run these capture the flag competitions to interest people in security, to find people who are keen and everything and get them interested in their company early on. So there are also vulnerable web applications which are used for testing, and security people use these as well. And both of these things as ways of testing each other and helping them learn skills. And Google have come up with Gruyere, which is apparently a holy cheese, because the idea is that this app's full of holes. There's WebGo, which isn't, it's kind of more a demo site, so it gives you lots of different sort of, let's just crank up the thing a bit, but it gives you various different things that you can have a play with. It's more of a, it goes through the OWASP top 10 and tries to give some example vulnerabilities and explain what the types of things are, and then you can actually go through the lessons and you can actually try and exploit something. There's a program called the Damn Vulnerable Web Application, which does what it says on the tin. And there are various other things. So you can actually gain practical skills and look at the code that is there, assuming it's open source, which as far as I know all of these are. Capture the flag competitions, the full source isn't necessarily all there, but often they'll give you, the source code for some of the servers. Some of them they expect you to do black box and just figure it out completely blind. So, as I say, it's practical experience that generally helps with developers, because otherwise what you end up with is kind of either people writing off vulnerabilities as being just not an issue at all, or you have the other problem where you have people seeing any problem as being absolutely critical, must fix it now, and using security as the sort of, the thing that, I'm trying to think what the word is, anyway, getting over the top of it. So being able to actually practically do these things and spot the vulnerabilities tends to be really helpful. And it will also help in terms of you'll be able to spot what the runtime signs are. So if you are actually having somebody hack your site, you might be able to tell what sort of signs you like to see in the logs, that type of thing. And also, you can actually play about and see what happens if you try and debug something and see what goes wrong, so that you can actually get a much more practical understanding of what these security problems are. So, on this tip as well, this is something I created relatively recently, because with Template Toolkit 2, and we're also using Template Ally, escaping things, it was getting really quite impractical in terms of just testing all of the various sort of things, ways that you could mess up in terms of encoding, whether you've got the right number of HTML, whether there's operator precedence and things like that, because it turns out that there are all these lovely subtle differences between Template Toolkit and Template Ally. Because using Template Ally with autofilter is great, because it actually allows you to just automatically escape stuff, so that you don't actually have to worry about whether or not the output is escaped or not. So if I just run this, so you see here we've got this dangerous thing that says, has a script in it, and a dangerous tag here, and you see here in the output, this is not actually ready as HTML, it's just spitting out the output of TT, but it's correctly HTML escaped it because it's got an autofilter. And it's really neat because it helps reduce the amount of problems you have when it comes to cross-site scripting on HTML. And so I created this little tool. It's a bit like sort of the JSfiddle and these various other tools online that allows you to just test out these various things. And so I also put in some examples into it of various scenarios so that I can help use it as an education tool, so that new developers can show here are the various escaping scenarios and these various things. And things like JSON as well. So if you don't have the default plugin, it doesn't actually deal with any script. So at our place of business, we've actually modified our JSON plugin so that it actually deals with any script tags, because that turns out to be something that sort of blows up browsers. So if I actually run this as HTML, you'll see here it pops up a little message box, and this is a useful way of being able to demonstrate things like that. So that's on GitHub if you do want to play with it in its own Docker. So it's a neat little way of just playing with Template Toolkit 2 and template coloring things. And I figured that sort of fits in the education thing as well. But one of the other things I just wanted to say is don't assume that developers can figure out security from first principles, because we generally crap at it and make bad assumptions. It's generally a good idea to actually educate people about things, because developers don't tend to think of half of the avenues that they can come up with. Things like blind SQL, if you try and do it as a developer and just try and exploit it yourself, you might come to the conclusion it's not exploitable. You know, it's a bad code, bit of code, but you can't exploit it, whereas in truth you can. You just put in some sleeps and presto, you can get the data out by side channels. But at the same time, not all security problems are solvable by developers easily. You know, there are some things where you should be outsourcing or, you know, finding experts. You know, some of the harder bits of cryptography. But there are education programs, things like the Coursera courses for cryptography, Cryptography 101 courses are really good, and that gets you sort of to be able to do an awful lot of things, and dealing with hashes and MACs and things really quickly and easily. And that was it.
I think we've probably got time for one question just while Simon's setting up. But